Hi, everyone. Great to be here again. I was in a bit of a pickle because I had to prepare two talks, one for yesterday, one for today, that were not technical. I'm not used to giving non-technical talks. So the talk today is short and very different probably from anything else you've seen in a while. We're late, so the fact that the talk is short, I think is awesome. So Peter asked me, he said, like, maybe you can tell people my story, right? And I'm like, I'm not dead yet, but maybe I can say some things. And the idea is here not to maybe you'll find something interesting here or something inspiring. I don't know. So like Peter said, we managed to dig out that I've been here almost exactly 20 years ago. If you look at the date, in 10 days or so, it will be 20 years. And this was like the beginning of my scientific adventure. This was 2 months or a month before we published this paper that kind of started everything. So it's great to be back. A few things about me. So I'm originally from Poland. I did my master thesis. So I first studied in Warsaw, then I came to Amsterdam to do my master thesis. At CWI, I defended it at Vrije Universiteit. Then I did, after a short break, I did my PhD at CWI. Based on that work, we started a company with Peter and a few other friends called Vectorwise. Then I left Vectorwise, joined Snowflake. Then I left Snowflake recently, and now kind of my main focus outside of like family and stuff is trying to help Polish ecosystem of startups through advising, investing, and so on. Also working with a bunch of nonprofits on things like that. So I think my career has been, I'll use the word career, but my story is somewhat unorthodox, and I think I achieved reasonable success. But it's not an accident. It was years of meticulous planning. Really. I'm an introvert. I planned everything. I analyzed myself. I analyzed the world around me, and every step here is fully planned, right? Not, right? You expected that, I know. So that's the story, When I look back and I think how I got where I am, it just sometimes blows my mind what happened on the way. So let's talk about, you look at me, baby, and you think, okay, successful guy, right? So let's talk about some failures. Oh, sorry, but I forgot about it. Background. Okay, somewhat important. So I come from Poland. I grew up in a communist country, right? I didn't have I couldn't get a computer because they were freaking expensive, right? So finally, but I was obsessed with them. I saw them, some friends had them. And finally, when I was 12 years old, I managed to convince my parents to get me a computer. A used Atari from our neighbors, which was 1.7 megahertz CPU, 64 kilobytes of RAM, and a tape recorder of 600 beats per second. So most of you here, or many of you here are born this decade, so maybe you don't even, sorry, this millennium, so maybe you don't even, sorry. Nice, right? Nice. Really young students here this year. And so the way I learned programming was through some things that are different than today, buying magazines, which had, tutorials and stuff, but also they had these listings of entire programs. It would have like 4 pages in a magazine, which you had to type into a computer to see what it's doing, right? So you learn a lot. You learn patience. You learn programming without typos and stuff like this. And then I spent many years in this community called Demoscene. Does anybody know what that is? Demoscene. Okay, few people, right? It's a community of people that try to showcase the power of computers through programming. And usually it involves writing a piece of code that shows some nice visual effects with music and everything. Interesting thing is, you work with a computer like this, you really try to squeeze every single cycle, every single byte. And I spent years doing that, on a slightly different machine than you're used to. But I think that shaped my mind, my brain to kind of really enjoy this programming and performance-oriented topics. And then finally got a PC and started learning things like Pascal and C, but that's I think what shaped me as a programmer were the years on this computer. So now, let's talk about my failures. I was finishing high school, and I wanted to get into the Warsaw University, which is the most prestigious computer science faculty in Poland. It's like full of people with brains like 2 times larger than mine. So I applied, and it's very hard to get into. Back then, it was like 1 in 20 or so. So I applied, and the first time I failed. I have a pretty good excuse, because I was telling Andy that recently. The day before the exam was at 8 a.m., I left the police station at midnight the day before. True story. Because we were robbed the day before. So like, it's not that I'm not smart. That's not why I failed the first time. It's that's the reason, right? So finally, I tried the next year, and then I got in. So that's failure number 1, right? Unexpected, maybe. Failure number 2. I was a student. We did, the bachelor years, and when we were joining the master program, you had to choose which seminar or like which professor you wanted to work with. And again, the most prestigious seminar were distributed systems. So what did I do? I had a group of 4 friends, 4 best friends, and we all 4 applied. And all of them got in. I didn't. What can you say? So I tried this thing called databases. What do you think? I did not get in. Did I tell you I was full of people with brains bigger than mine? That also means their grades were better than mine. So then, there was this other seminar which also has the word data in it, deductive databases. Does anybody here know what it is? So things like Prolog, logic, very weird stuff. There was a theory session about it today. And that's what I was doing for a year. So I learned a lot of really obscure things that had the word data in it. So these were the failures, but then some interesting things happened. So the year was 2001. I was in the 4th year of my studies, and I was planning to just follow the usual track. And then I met a friend. I vividly remember that encounter in a corridor at the university, and he spoke these words like, "Hey, do you want to go to Amsterdam? There is this new program, exchange program, where you can go and get a master's degree from a university in Amsterdam and a university in Poland at the same time." I'm like, that sounds awesome. Oh, and they pay for you, right? So sounds awesome. So I applied, and I got in. And here's the catch. This was the first year of that program. So if I got into the university the first time, I would never be here, right? So that failure allowed me to come to Amsterdam. Happy accident number 2. So I came to Amsterdam. I was looking for a master thesis supervisor. And because I came from this theoretical databases seminar, my idea for a thesis, and I don't know who will understand it, but was to build a simulator to run SQL queries on a concurrent read, concurrent write, parallel run machines. They don't exist. They're theoretical machines. But they have this amazing property that any SQL query, any relational query, can be evaluated on a machine like that. Do you know how fast? Nobody really? In constant time. Constant time. Well, you need a polynomial number of CPUs. Or kind of the exponent based on the query complexity, and kind of the base is based on the size of your data. But it still sounds cool, right? So that's what I wanted to do, and it had the word parallel in it. So there was a professor at Freie Universität called Henry Ball, and he seemed like a great choice. So I went to him and was like, this database stuff, talk to these CWI people. Okay. I went, spoke with Martin Kersten and Niels Ness. Niels is here. Martin, unfortunately, is not longer with us. And they convinced me to, we're doing real things here. And what I really liked is that they told me work on performance. So the stuff I really spent years working on. Slightly different performance, but really performance. And guess what? This wouldn't have happened if not for failure number 2. If I got into the distributed systems seminar, the most prestigious one, like my best friend, I would probably end up doing my master thesis at Vrije University with Professor Martin van Steen on distributed systems. So again, completely unexpected outcome of what I considered was a failure, right? So probably there is a lesson here. So I was doing my master's, and something unexpected happened. So I worked on parallel query execution in MonetDB, and I spent a few months inventing different algorithms, how to run MonetDB in a parallel way. And then I found one problem, and I wrote this one paragraph in my thesis. Without going into too much detail, I'll say it's like, we divide the data into smaller chunks that are small enough to fit into cache memory, and they can be reused without causing main memory traffic. Those of you who know what vectorized query processing is, this is it, right? The thing is, I didn't understand it. Really. I didn't understand what it means. It's like, this is the idea. I don't know what to do with it. I defended my thesis, and I returned to Poland. Luckily, there was this guy, Peter, who something must have clicked in his brain. And he took this idea, and he built a prototype based on that, which showed that this idea can be converted into technology that is amazing and is now used by everybody, and it's great. But it really came from this kind of a side thought almost, which is like, with a hindsight, kind of mind-blowing. And then I started a PhD and everything. Okay. Another unexpected result. Like I said, this is not like a very structured talk, just a series of random stuff. So in 2005, I went for an internship to Microsoft. And here's one thing I want to urge everybody here. I mean, especially students and PhD students. If you haven't considered doing an internship, please do. Because that's something that people in Europe don't do enough. And I think it's great for you as a student in so many ways. You can make money, but they pay a lot. You can also learn new stuff. You can build contacts that might be useful if you don't end up in academia. So it's great. But anyway, I was at Microsoft, and I was working on some DML stuff, of course, performance related. And guess what? I spent 3 months on work that didn't end anywhere because I implemented the idea that somebody gave me, and turned out the idea wasn't really that good. But as I was working on it, who knows what a B tree is? Good show of hands, good. So B trees are used by SQL Server for storing data in indices. And I noticed that like the fill factor of leaf, that's somewhat technical, of leaf nodes, by default was 100%, which means if you loaded the data and then you added one record, you had to rearrange the tree. So it made all my experiments wrong, kind of slow. So I just changed the setting, and then my experiments were OK. Still not great, but OK. And I was giving my final presentation about my internship, and I mentioned that in the talk. You should have seen like the face of Gus Grafe, who was like the manager of the group. He was like, really? That this is our default setting? If somebody knows a bit about B trees, that's Gus Grafe. And this was an unexpected result because everything I could have done with this DML project, probably the impact was much smaller than this one finding. Next year, I did another internship at Google. I want to urge every student here to do internships. And guess what? I was working on a new database engine. I think in my career, I worked on 6 total, and this was one of the, one of these. It was a small project. It didn't go anywhere. Although, I think it gave some ideas for the team that later started F1, because that was in the team that was in the F1 team. So Bart, yeah, that was in the same group. And an interesting aspect of this project was, who knows what protocol buffers are? Okay, quite a few people. So in protocol buffers is the standard data format used by Google and by many more companies now, like gRPC also uses protocol buffers, right? And for serialization and deserialization of application data. But I was writing, typically what happens is you know what your data is, and you use a generator to generate serialization, deserialization code. But the database that processes protocol buffers needs to be able to process arbitrary protocol buffers from different sources. So I had to write my own protobuf parser. And when I was looking at the code, I noticed that the code generated, so there are two things. There is every field in protobuffer has an ID, but also kind of the physical order in the file. And they don't need to be related. So I looked at the code and I said, like, in some cases, they seem to be like doing the code like they prioritize this order, in some other cases in this order. And like, is it supposed to be like this? I wrote to the protocol buffer maintainers, and the answer was pretty much this. And a few weeks later, they aligned it to do it all in the same way. And protocol buffer performance went up a few percent across the Google fleet. Again, my project was a failure completely, but a strange side thing led to, I mean, it paid for my internship like many, many times, for sure. Okay, so anyway, I was finishing my PhD, and based on that work, we started Vectorwise. We sold it in 2010, and it was supposed to be short, but I'm taking my time. And we sold it to Actian, and 2012, I wasn't happy, and I was planning to leave Actian, and I was flying to San Francisco on Saturday, particular week, to tell my CEO I'm probably leaving. Saturday. The Friday before, I'm getting this email about Snowflake systems. The day before. And I'm like, I'm not looking for a job, but I happen to be there tomorrow. Right? So I met, for the first time, I met Snowflake, Benoit and Thierry. And the thing here, if this email came like a month before, I was still trying to make things work. If at Vectorwise. If it came 2 weeks later, I would be back, and I'm like, I'm in Amsterdam. Why would I talk to these guys, right? So how insanely perfect that timing was is just, with a hindsight, blows my mind. And this is slightly, maybe I'm trying to be funny here. So unexpected result number 4, which is Snowflake has multiple dimensions of concurrency. One is scaling for storage. So like we put the storage in the middle, right? Then we put what we call vertical warehouses around it. And there is, they can grow and everything. So after working at Snowflake for like 2 years, we drew it on some whiteboard, and somebody said, do you know what this looks like? It looks like a snowflake. So that's a kind of unexpected result. Maybe not a very useful one, but still cute. So with a hindsight, I will not deny that, where we got is a result of a lot of hard work. But when I look how much pure luck or chance was in it, you should never underestimate it. And some failures, as I have shown, can lead to great things. I mean, I wouldn't be here if I didn't have some failures on the way. And also, some of these completely unexpected results you don't find maybe interesting initially can turn out to be really, really useful and valuable. So look for these as you work. So like I said, this is a slightly different talk, but hopefully you found it at least somewhat interesting. And so thank you, and I'm happy to answer any questions.